Hello guys, this is the first video that I'm gonna call, rather than solvers like the previous video, this is the first video where I'm gonna start discussing about, prepping everything for generating something a bit more complex with a much more complex behavior. And from there on, where solvers are, atomic functionalities that provides basic matrix transformations, I want to be able to assemble these solvers and controls within something a bit more complex, and we're going to call those modules. Um, a module, it's rather than being a simple IK, a module provides a much bigger uh, or a broader behavior. And a classic example of a module could be an arm with fingers and an IK, FK, stretching and switching and stuff like that. I'm not going to complete the R module today. And again, the reason why I'm doing bit by bit, one way to show this would be to simply build an arm with control rig and give the final recipe to do it. But there are two reasons why I'm not doing this. While I'm learning, I'm still not sure what the final recipe looks like. And the other reason, to me, it's way more important to provide the ingredients on how to build your own recipe for an R module, because rigging, you don't ever create the perfect rig for an arm. It depends from many factors. So I would rather build the portions, the Lego blocks, instead of the final module altogether. This allows for reusage and I think a better understanding of how a modular system works. Anyway, couple of things before jumping into Unreal. While I was while I'm learning and debugging, etc., you may have seen that I have those cubical, no, not cubical, cubic geometries that are aligned to a skeleton. Well, because I was doing that over and over again, I built a little script, and you should be able to find this little script in the description of the video. And this script is is not that smart. It's a simple script to say, I want a cube type, and I want the scale. What it does, it builds a geometry and connects it to it. And the way this is a unique geometry, and each segment is automatically skinned to the right joint. So you only specify the root name, and then what you have. And the reason is, well, I like to have both a skeleton and a geometry representation, a skeletal mesh in Unreal. So, but this is pretty much it. The other thing that you can do is I found this to be really interesting when I was working in the body. You can use another. You can have the instructions here. This is a very silly way to give you options, but I'm not gonna change that. This is stupid enough. You can change from cube to point, and point it's just a name I gave for having a bone plus joint shape. And let's put this and let's see what it does. So this is what it does. It basically turns the skeleton into a geometry, and it works the same way. So, and again, this is more, the cube are mostly enough, but this is sometimes I found really interesting the way bones underneath bones behave. So that's more why this kind of visualization exists. In Maya, is a bit hard to see a rotation of a bone. Let me give you an example. Otherwise, you'll say, why are you building this? So there are many ways to display things, but to get that into Unreal, let me. Oh, where is this joint? Great. Okay. Have I lost a joint? I don't know how to create a bone apparently. I don't know what happened there, but anyway, so you have a joint here, but in Maya, when you rotate it like that, and you see around this, Sometimes you get lost with joints upon joints and upon joints. So instead of, I found it that is much better to see it with a geometry. That's all. That's really it. Let me reopen it. What was it? Module R. So let me rebuild this. Oh, I came in with the namespace. Okay, let me rebuild this. Sorry, it's a really long intro. Cube, let's say scale 2. Awesome, I'm happy with this. Let's save this as module arm, yes, and export all as module arm. Now we go into Unreal. This should be already in it, but I'm going to import by using the latest. Here we go. That's what we have. Great. You can see that. So we now have the skeletal mesh. As I said, we're not going to complete the arm module because first I wanna start start building a library of not just solvers like we did, but also functions. And this is one, like in the previous video, this is one of the reasons why I moved to Unreal 5. So when I was working in those solvers, there is a couple of things that I'm doing over and over again. In the setup event, I'm aligning controls. And in the forward solve, I'm doing pretty much the opposite. These controls that are now aligned are driving now the bones. So I wanted to come up with a quick way to debug things when I'm doing this stuff. So I built two functions and I want to have a look at those two functions. So the first one, I call it control to bounds by name. And what this function does, let's ignore the branch for a minute. What this function does, and I'm following the false branch, what this function does is by default, it says controls to bone hierarchy. It takes a partial name like twist, and then it finds all the control with that name. And for each of that item is getting the transform of that control, is substituting the parameter that is passed as master suffix with the slave suffix. Okay, so here we have all the controls which start with this rule, and then I'm taking that name, substituting it, and if the object exists, it's going to set the transform of that bone based on the transform of that thing. Once the loop is done, the function is going to return. Okay, then, and this is basically a way to quickly do something like in the forward solve where controls drive bone. Now let's jump into the hierarchy for a minute. Into the rig hierarchy, there is a bunch of controls, one on top of one another at the origin. These are, everything is at 0, both the offset transform, the initial transform, and the current transform. This is the rig hierarchy, and so this is how it looks. Of course, because I am building a procedural mechanism here, I'm relying a lot about names. You can extrapolate it some additional data by being smart about the hierarchy, looking for the children, the leaves, or the root nodes, but using names, it's a bit better, and I believe it's a bit more versatile, especially if you expose the name as a variable. And by name I mean, you know, the like I was doing in the other videos as a partial name. Anyway, so now let's analyze the branch. I have an additional condition, and it's an attribute that is called flip, because basically in the setup event you're doing exactly the opposite of the forward solve when it comes to pure FK stuff. So let's see how this works. It's a bit better probably to show it. I want to say that index is at this very moment, this is how you read this function: controls to bones, right? So in this specific function, I will take index controls and drive index joins. If I flip, you have to imagine that this name is flipped, bones to controls. You don't have to change anything here. You want to say index flip bones drive controls. So you can see that this instant I plug the thing, instantly these got connected. And the reason why I implemented the flip is because of this. I can duplicate this node now and connect it, and this is how it looks. It's instantly connected. The reason why this bone popped down is because I didn't recompile, and I on purpose have no propagation on bones. I don't want the propagation to always happen. So I guess we have now, let's create a sequence first of all. It's just for readability. So I'm hoping that it's becoming clear why functions are very important, because just with Node I can replicate behaviors all over the places without complicating the graph. To me, ideally, the rig graph at this level should be very high level in terms of functionality. It should have functions connected together, saying build fingers, build the thumb, and build the arm. Thanks. Internally, if you're smart enough, we can build subgraphs of functionality that take care of building the high level behavior that we want. So another function, let me create a sequences here as well. Let me disconnect all of that. Another function that I've made is very similar, but rather than that being by name, I'm building by hierarchy. And the reason is there might be instances where the names are not like middle. I rather want to have a hierarchy where the names are different. So I'm specifying only the first and the last one. So in this specific example, it's very identical. But rather than using, see, this is controls to bones by hierarchy, and this is controls to bones by name. The only difference really is this node I'm using at the very beginning. This one specifies the label at the beginning, and here instead I'm specifying the first and last item, depending if there is the flip, turn on and off. These graphs are identical basically. The only difference is the flip switch. So bone, control, bone, control, control, bone. Okay, so let's see if by adding this function, hierarchy, see this, and let's say, yeah, these were the presets. So in this case, I want to have the env driver, sorry, env hierarchy, and flip it. And basically this is what happened. You can see that now all the controls that already exist are already aligned to the corresponding bones. And after that, I want to run this one. And let's say instead of index, I want to create middle. Boom. You can see that now it's very simple, and the graph it's very simple. You can say here you can tell immediately I'm aligning the clavicle, the finger, the middle finger, the index finger. So let's take all of this away. Let's duplicate this graph. Let me okay, I missed it. And now we're here with, I can flip this, unflipped it, sorry, because now I really want controls to bones. Here, instead of passing the hierarchy, I want to pass the actual control, but I don't want to flip it. So I just duplicated the graph. So in theory, if everything worked fine, I expect, let's see, because I'm not propagating anything, I expect the thumb, the ring, and the pinky not to move when I'm gonna move this here, but everything else to move accordingly. Let's see. That's exactly what's happening. And this is actually, it makes sense because I haven't rigged these bones here, and because in none of the function I'm using propagate to children, and these bones won't be affected. Okay, so there is one thing that is not working, and is the fact that these controls are not moving the bones in here. So let's try to debug this. So right now I'm running controls to bones by hierarchy, and I have control L control upper arm and hand L control. So here's what I see. The controls are aligned properly, so it means that this has worked, but the controls now are not basically moving the bones. So let's see what's going on. Clavicle, we're taking these 1, 2, 3, 4, and we're substituting the word control with word env. And if I jump into the false, I'm taking the control, and it said there is a warning here, and it says control none is not valid. Let's see what that means. You can see that the warning is gone, but the problem is still there. So what happens, for example, if I say I don't want to be an issue? Okay, let's see. By the way, this is the problem. I just want to point out, you can see that basically this is now working. So what I was doing here, I was basically constantly saying that the position of the control when moved was updating the initial position of the bone. So that's why nothing was happening. And this is now the actual function that is working. So this is just to clarify that, the cool things about functions is that I toggle this on just so you guys can see that, the cool things about encapsulating everything in a function is that if you find a bug and you don't have to, this bug will be propagated everywhere, so it's really easy to spot. But the cool thing is, because it's you're using the same function all over again, by changing the function and fixing the function, the bug will disappear everywhere. So sorry, that took a long time but that's what I meant. All these controls were failing, right? Let's do it again. All these controls were failing, and so because it's a function that it's across a big area of the body, for example, it's really visible. It's not a hidden bug. This is clearly broken. But because I'm using it all over the places in the function, just by fixing the function, everything starts working again. So this is the first part for the module. These are the basis, the basics I'm going to rely on when building a more procedural approach. So the idea of encapsulating function within function and then having just high level behavior and the high level graph, to me it's very powerful, because for example, we can now build, and we will build, we sorted out pretty much anything that is FK related with joints that are matching. The only way we need now is an IK behavior, and somehow implement this clavicle and IK switch and matching, and then that will be it for the arm. So in the end, you have a high level graph with micro functions that you can reuse, but is modular enough where you can change the input bones values with your own custom bones, and everything should still work. A little note before I stop talking. Right now, these functions are embedded within the rig graph, meaning that only this control module has access to these functions. Now, I haven't found it, but I wish when you create a let me blueprints. So I wish control rig had something like what is called blueprint function library or macro library, where you can build all these utilities in a generic node, And then all the control rigs can access those functionalities, because if you build them generic enough, then you can instantiate those functions within your rig graph. Right now, I cannot really duplicate the control rig, change and point to a different function. The only way to access the function is within the. So I'm hoping that Epic will fix that, unless I'm mistaken, and this node does actually exist, but I cannot find it. This is just the Gizmo library, which are the shapes. We're going to talk about that later. Anyway, that's pretty much it for today. Bye bye.